minutes to join, and I should be on the way. Today, it's a very interesting realm to be in. The reason why we're now stepping into the overarching concept and fundamental of programming. What we were doing before is specific to the web. What we'll be doing today will basically set you on a path to actually learning any programming language because every programming language fundamentally follows these same sets of principles. So once you grasp it today, you'll be able to grasp almost every programming language because these are the fundamentals. I remember expressing before that if you grasp the fundamentals well, then you're fully on your way to learning anything. And if you learn how to lay the first brick, then you can eventually build a skyscraper or a house. With some additional engineering, but it just takes practice, it just takes work. It's good to have you guys join us today again. Really hope today will be worth your while. As I said, today is a very interesting class for me because, like I said, we're on the path to full-on development and appreciating coding at its fundamental level. So, welcome again, guys. Welcome, everyone. And every day the same prayer I pray. Say yes, and every day the same prayer I pray. And I'll say to one more, oh, it's up there. Never let fire burn. Peace. That's just what I see. Yeah, I love stocks. Like stocks for me is like a game. I understand. I love it. Oh, for real. But all right, pause before I commit. No, for me, it's just like how do you take your money and just sit around a computer and make more money, which is just a dollars and cents game for me. It's like it's so easy. Like once you grasp the fundamentals, you're buying into official companies doing the day-to-day work, and you just put in your money there to make it work. No, it is so simple. Like I've never seen an easier way to get rich. Real estate and every other thing they're there and they take long-term periods. But stocks, if you really work it, well, the unnatural way because the idea is to wait 10 to 15 years so maturity. Yeah, but before you even get there, like for example, COVID, I made 300% on earnings. So imagine you invest in like $1 million, you make like $3 to $4 million in 3 to 4 days. It's just like where else? No, I don't do overseas because I think Jamaican market is good enough for me. I don't want to bombard myself with the aggression of the overseas market. It's a bit more fast paced. Jamaica, you take a good amount of time. You know exactly what the companies are doing because you're personal with them. You're experiencing the climate, the economy. So if you're there experiencing it, you know exactly what will be shifted. Like CPJ for me is a prime stock. Like I like it. I never liked it before, but given the current climate, because they're the biggest suppliers of like alcoholic beverages to hotels, and if the hotel shut down, oh, you know what? That's fine, no, because I don't know the check up all this thing, like, yeah, man, just whatever it is, I just. Yeah, man. Oh. Yeah, man. So as I was saying, it's like the hotels them closed completely, so the business is affected. However, a lot of people is overlooking how much money they made during the IPO, which is the initial public offering, right? They have a lot of money saved up. They can suffer. They can go through this climate without being affected at all. And it's run by a wealthy family, so they just lock the business and just throw in the key and left it and make it just stay until everything is over back and it go straight back up. I tell you, it's just like right now in the COVID period is a time where millionaires are made or created. It's like there's so many opportunities in the market. A lot of people seeing it as negative. I tell you, yo, when COVID done, you'll be seeing some different type of people coming out. People are gonna become millionaires in these times. People are gonna become wealthy. They in a pace where them just can't They never imagine themselves ever being. That's why I say it's like don't surrender to the panic. It's like during this economic time, you have to just maintain your composure and work with the climate. See it as it is. Yeah, you have to just keep your composure. I'm gonna tell you, man, it's just like there are ways to make money. Barry to APO the other day give about 25 to 30% return on your money. You know, get them thing until you invest in like some life insurance plan where I collect from 65. 30% paying money, dog, that's ridiculous. You get the message? So it's not a big gain compared to what you can get. And like I said, like key insurance in COVID time, 300% increase, 300%. During COVID, that is what? During a pandemic, you're telling me that I'm making 300% of my money during a pandemic. It is just a bit like
Where's the podcast? There's nobody.
Say what I said. So you have a suite of like stuff that you have like an investment portfolio, right?
yeah, I invest in other things. So I have a life insurance plan, a critical illness plans, so that can benefit. I'm looking into real estate. Roxy is heavy in real estate.
Yeah.
I buy stocks heavily. Like stocks is my main stream of revenue right now. Outside the companies I buy, right now I have shares in Wisinko. I have shares in Indies Pharmacy, which is
Yeah, man, I know what it is.
Indies is just it's just beautiful. It's run by Indians. It's fascinating. What else I have Kingston Wolves. I have. Let me tell you what else. I have to check my list and make But I invest. Like my max is usually 5 to 6. I don't invest in more than 5 to 6 companies.
Yeah, but I'm actually, so I have like, so my thing, I have like NCB,
Yeah.
I have JMB.
Share NCB. JMB is a good stock as well. Yeah.
What I'm trying to do is actually invest in companies that are really, really good. Because I'm not an empire. I'm thinking about like, okay,
Like blue chips.
I just forget what I think I just buy and retire.
Oh yeah, so some people work it that way. Yeah.
I'm not as passionate as you are.
Oh, no,
So my interest is not really in. But you know, my thing is okay, let me just consistently, because it will compound.
Yeah.
And that's my idea, right? So just small steps,
Yeah.
and eventually you'll have excellent.
It's like an exponent, and that is what us millennials, well, people of our times, Gen X, Gen Z, millennials. It's like we don't understand the beauty of compounding. Everything we want, it's the ultimate win, brother. You see, right now, when you invest from, like, I've been investing from when I was 20, dog. Like, I started a fund for my kids, and I don't have kids already. Valuing over millions of dollars already. And I tell you, when they're born, just imagine when they reach 18. They're not worried about university. Like, I'm planning this, like, from a start work, I start account for them. Steadily pump some money monthly. It's not no risky. It's like 10 to 20,000 a month, right? I just putting it in there, just setting it aside, and I have like 2 to 3 of those accounts for them. I just imagine when they're born, when they reach 18.
They're not worried about.
Brother, them can buy a house, them pay for university, buy a car, buy a house. Bro, them can do anything they want. Exactly. It's a time game. It's a time game.
So for me, it's like, okay, so I have like, because I actually started when I was
You started when?
investing when I was 24.
Oh, 24.
Like what?
We could continue after. No, I said we can continue afterwards. But I tell you, man, it's just I've never seen an easier way to make money. And you see, like I said, for me, money is not the focus. It is just like if you can make it easily work for you, if I can do nothing, if I can sleep and money does a gain, like I'm living my life, bro. I'm so happy. Like them opportunity exists. Me, I tell me, so me can log into a portal, put my money there, and make how much percentage return by my money without doing nothing. And I own a business on top of it. So it's like the multiple streams of income is just like fascinating. It's just you have to work hard. It's a lovely thing, man. It's beautiful. Sorry. All right, so I'm just going to kickstart some things with class. Even though Dre was recording my stock conversation. Sorry about that, guys. So we went a bit over time in that discussion just now. But like I said, welcome again. Today is a very exciting time for Nyla. Reason being, as we said before, we'll be learning a lot of the fundamentals of coding overall, as opposed to web technologies. So HTML, CSS, and JavaScript, they're web technologies. However, JavaScript in itself can be used outside of the web. Like I said, you can use it to build car radios. You can use it to build, to power car radios. You can use it to build microprocessors that work inside your cell phone. You can use it to build mobile apps. You can use it to build almost anything you might think of. And that virtuality allows you to just live on any device you run JavaScript on it. It should be able to power anything. Um, yeah, so without further ado, I'm just going to get started. So I usually start with a recap, but I feel odd going forward without the beginning. There's not everybody here. You get me, Dre? So a lot of people isn't here, but this topic is so important. But what I'll do a recap next week if anything. But I want everybody that is here that allow the time to be present here to just benefit from it. So I'll just get into it on the list. Yeah, I'll just do a recap next week. See, I see this one for the mark. Yeah, sorry about that. Alright, so let's test in the markers. Testing next one. Alright. So we started the class saying that programming in itself is really giving the computer instructions. So it's like if you're expressing a message to someone, you're just asking them to do a particular action. So for example, I would say, let the boy walk, let the girl talk, let the other express themselves through dance or creativity. Programming itself is fundamentally the same, telling the computer exactly what to do. And then anything that it does is it never does anything out of its own will. It's usually what you tell it to do. So in grasping that concept, it's like programming puts you in a position to just express. Right? So you're expressing a computer, you're creating this machine or instructing this machine to do a series of steps. Right? But how do we go about doing that? Because we've been talking a lot about HTML and CSS, but how do we properly digress information into the computer so you can perform a series of tasks or a series of instructions? So for that, a key thing about it is really grasping what it runs off. So it's like you're trying to build a computer to perform a certain set of functions, right? You need creating its functionality. So in the core of programming in itself is built on functions. So most things or most actions that you want to carry out is really through functions, right? And I think you guys have grasped a lot so far. So the introduction of functions will come as scary to you, right? So what a function is really an instruction. So you compile instructions into a series of functions, right? So if we're saying that let the boy walk as a function, then you can literally just say let the boy walk as a function, right? Because that function in particular will be responsible for a set of duties that is involved with the boy walking. So let me demonstrate that. So I'm going to create a function called boy, right? So boy, and in programming world, a function usually has these two squiggly things. You don't need to worry about it. An additional squiggly thing and an additional squiggly thing. So the idea here, without getting too complicated, I'll just remove this because this is just syntax. The idea is you're defining a series of instructions that can be called anywhere in the programming app, right? So let's create a function that instructs the computer to turn on. How you write that in programming world is really creating using any name. So call this turn on, right? Just an open bracket. Squiggly line, open bracket, sorry, and close bracket. So we're asking the computer to turn on. So maybe you'll have an instruction that says um, boot. So we'll press button, right? Press the power button. And the next thing you do is probably have it turn on, right? So when you press the power button, the screen is supposed to change its appearance, which provides light to the screen. So change screen appearance. And the reason why I'm doing it in this manner is really we're getting into the grasp of giving it instructions. So any way that we can formulate a set of steps to solving a particular task is what you basically put inside the function. But this is just introducing the function. before I dive into that, though, I want to speak on algorithms. So I don't know if you guys have ever heard the word or heard the term algorithms before, but algorithm in itself is really a set of steps. It's just a set of steps to achieving a particular task. And most things that you build has an algorithm, is an algorithm. So if you're constructing a website, what do you want the website to do? What type of functionalities do you want to apply to the website? If you're building something that powers a car radio, what would you want the car radio to do in specific times of such and such, right? So in essence, you're defining a series of steps that leads to the computer executing a series of things. So the computer in itself has this linear sequence when it's reading a set of instructions. So let's create an algorithm to create to cook some curry chicken, right? Curry wood or whatever. It's fundamentally the same. It's just a series of steps, in essence, that you're giving the computer to do every step of the way. So let's say we're going to make curry chicken. The first thing we need to do is what? We probably need to go to the supermarket. All right. The second step is picking up chicken, right? Pick up seasoning and chicken. Second thing we don't want to do is we'll take it home, right? So take it home. Third thing we'll do is probably prep the chicken. So cut up the chicken, right? Huh? Oh, the fourth thing, sorry. Chop the seasoning, right? And well, I'm just going to escalate the process. You rub everything in and then you start the cooking process, right? So cook is the final thing that you're trying to do. So these are set of steps that lead to you executing on a particular task, which is to cook the curry. It's the computer works the very same way. So if I'm going to tie it back to what we've learned so far, it's just like let's say I have a button on the HTML page, right? Let me just erase this algorithm. So if anybody stops you on the street and asks you what an algorithm is, fundamentally it's a series of steps that leads to the execution of a project or something or to achieve a particular task. Just a series of steps, right? So let's create a button on HTML, right? So we have a button here, right? That says, in essence, you want it to show an alert. So probably alert, right? So we have the button on our website. And what we're trying to do is instruct that button to show an alert whenever it's clicked, right? So in essence, when I click this button, I want a function to execute that shows me an alert, right? So in clicking this button, I really want to create a function that allows it to show an alert. So now I'm probably going to call the function, let's just call it function for now, right? So function, because JavaScript uses a lot of functions, but we're not diving into JavaScript. Like I said, this works for almost every programming language that you'll ever grasp. But you create a function, right? And inside that function, so I'm just going to create something that opens and closes things, similar to HTML and CSS. They usually follow this method where you have to encapsulate the instruction that you give into the computer. So we have this button, and we want when that button is clicked, it fires out that function that shows an alert, right? So in most programming languages, especially one built for the web, you'll have something probably called alert, right? So inside that function, we can call another function to perform the alert. So in this case, let's call it alert, right? So alert, and in the alert, we want to show some message. So alert, welcome to my site. So every time I go on the website and I click alert, it should show something that prompts to me that says welcome to my site. And really, this is fundamentally what functions are. It's just like assigning series of tasks, a specific list or a specific items on a website. If you have these things in place, then the website will know exactly what to do whenever an action is performed. So in saying that, I really want to just do an introduction to JavaScript. So I stated before that CSS is the skin of the web, right? I've also stated that HTML is the skeleton of the web. So you have the skin, you have the skeleton. However, you need something to perform some amount of functionality. You need to move the hand to the right, you need to move the hand to the left, heads up, heads down. JavaScript allows you to power the web in that manner. So without JavaScript, there's no way to click a button. There is no way to show an alert when a button is clicked. There's no way to do it at all, right? HTML by itself cannot do that because HTML doesn't have functions. CSS by itself cannot do that because CSS don't have functions, right? JavaScript in itself provides that function or those functions that the web carry out. So let's say we have another picture. We want to create a slideshow, right? So we have a series of pictures, and in essence, we want them to slide across. So I'm on the website, and when I visit the website, I'm seeing one picture, then it slides. I'm seeing the next picture, then it slides, and I'm seeing the next picture. Those are also functions too. So the essence of it is, see now we just created an alert function. We're going to create a function that allows things to slide across the website. So create another function here that says perhaps slide images. It's a lot more complex than that, but I want you guys to grasp the fundamentals because then you will get the hang or the knack of everything. So with functions now, functions allow you to create something that you call variables, right? Variables in itself can be an item, a singular item, or an action. So I don't know if you guys have ever taken a deep dive into anybody's programming language or something they've written. A lot of the times it's not the syntax that scares you, it's the words that are there that you don't comprehend or see what they mean, what do they represent. So it allows you to create unique function names. So ideally, I can call a function something else. So my function probably is responsible for sliding images. Instead of call it slide image, I'll probably call it turkey bacon, right? So I'm saying people are tricky like that, and once you grasp and once you're able to differentiate what a variable is as opposed to a predefined function that is defined in a programming language, then you can really lose your way in somebody's code. So the idea, as I said, if you grasp the fundamentals and know exactly what these specific functions do, then you'll truly tremendously benefit from, you basically grasp or gain the ability to read code better. So like I said, people have that flexibility when they're creating functions. They have that flexibility when they're creating data types, and we'll get into soon. They have that flexibility when they really doing anything. If they falls outside the jurisdiction of those programming languages or those functions or those core functions, then you can name it anything you really want, right? So let's take some steps back. So in programming, there's some amount of fundamental things you'd want to do on the day to day, right? You'd want to probably loop over something, showing many things on the screen without writing it many times. So if I want to show an image or 10 images on the page, and I've already created an HTML tag to show that image, I can just call an iteration, as they call it, or a loop to show the 10 image or those 10 of those same images, as opposed to rewriting that 10 image at the same time. There's also something you call decision making as well. So if there is a female present on the website, show her this content. Else, there's a male present, right? So you condition it and you choose specific things to show on the website based on the gender that is visiting your website. So it allows you to just have conditions, right? Another thing you want to grasp is variables, as I listed before. Variables in themselves is just giving a value a name. So it's like instead of writing number 10, I can assign 10 to turkey bacon, right? And then turkey bacon now represents 10, right? So yeah, so you have variables, you have iterations, you have conditional statements, and that's pretty much everything you need to know about functions. So once you have the grasp of those three things, then you have the grasp of every programming language, because every programming language fundamentally has those three things, right? So as I stated before, variables, iteration, which is really looping the process or multiplying the process over a series of instructions, and decision making. So you come to a blockage, where do we go from here? So let's play a game, right? So we're going to create a track, right? Just a track where we're going to lead this spot to this to the end of the tunnel, right? So ideally, what we want to do, we want to. Oh, you're not seeing? All right, let me use the blue one because I think the blue one. All right, sorry. Sorry about that. So this is one of those topics, guys. Trust me, it's not something that you see come to life immediately. It's really a back end topic. It's one of those topics where you not see things. It's just about grasping what the concept is. And once you grasp it, you start to see the beauty of it once you start going further in the class. But bear with me as I go through the fundamentals. So as I was stating before, I'm just going to create a track. So we're going to play a game, right? The idea is to move this ball to the end of this tunnel. So we're going to train it to operate on its own. So it's like whenever you come up to a roadblock, what is it supposed to do from there? When it comes up to another block, where is it supposed to go from there? The idea, so we're going to create an algorithm to power this bot to carry out a series of instructions to get to the end. All right, so how we'll do that is, let me just turn this a little bit to the right. All right, so a way we can go about this is creating something that they call a class, right? So this is the class of a robot because class, just like HTML, it basically encompasses a group of robots. So we're not creating this app or this platform for this specific robot. Maybe we want to duplicate it across a series of robots, right? So here we'll create a class because we're trying to, as I said, build for many robots and not just this specific robot. So let's call the robot class. So we'll just call it class robot for now, right? And then inside this, we'll create an algorithm that defines what the robot does in its navigation, right? So this class robot will have to have a series of things or a series of instructions that move the robot from one point to the next point, right? So in essence, what we want it to do is move forward, right? So that would be the first instruction that we give to the robot. So move forward can be a function, right? So we're defining the functions without giving it the core functionalities, right? And as it's moving forward, right? It's moving forward, it's moving forward. Eventually it comes up to this blockage. It doesn't know what to do because you just instructed it to move forward, right? So it's just continuously moving forward, bumping into things, bumping into things, bumping into things, because there's no instruction for it to navigate if it comes to a block. So the idea here is we're going to define what should happen if it comes to a block. So just like I've said about conditional statements, this is just another way of saying what if the robot is to come to a block in moving forward. We need to handle it without having to tamper with the robot's ability to get to the end, right? So we already defined the instruction to move forward. So move forward, move forward, move forward. At this point, we have one move forward functions, but let's say the robot has to take many steps. So that the square represents the steps to get there. It has to take 4 steps to get to where it needs to be. So before we get into iteration, we're going to speak on, no, before we get into the conditional statements, we're going to get into iteration first, right? So we have this move forward, but it can only move forward once. So we have the option to, right, move forward again, right? And it moves forward one more time, and we can write move forward one more time again, right? Not going to write it out, and it moves to the next square, and then move forward one more time, right? So you realize that I am repeating myself continuously, but I just want 4 actions for the robot to get from point A to point B. And I just don't want to write this many times because it can be convoluted. You know, imagine if I have 4 of the same functions in my program. It's not efficient, right? And that is when they introduce something that they call iteration or iterative types. So iterative types can come in many forms, right? Many forms. So you have a for loop, right? They call it loops as well. So you have a for loop. Just ensure that you're seeing the screen. You have a for loop, right? So for loop. You have a while loop. So while loop, and you have like a do while loop, right? So do while loop. So the essence of it is each of these specific things or each of these specific loops have their own ways of doing things. And the idea, as the word suggests, loops, it's just to repeat a process how many times and define how many times you want to repeat that process. So as I stated before, right, we already have the move forward function. We created it. So why do we need to write it 4 times? Can we just tap into one of these loops to execute on this thing or this action 4 times for me? Yes, we can. So give me a sec. Right, so we're here and we don't want to be writing move forward over and over and over and over and over and over. Just imagine a program with 100 lines of moving forward. Imagine this has to move from here to probably Trelawney. There's many turns, there are many crevices, but we needed to understand how to get there because we already have the map and we're trying to define how it gets there. So just for the person that has joined, each square represents the set of steps that the robot must take in order to get from point A to point B. And I was asking them to bear with me because this is one of those topics that you can't see the creativity immediately. It's mostly the functions because when you go on a website, they don't say, you just see the button or the button jumping up and down. You really don't see what's causing the button to jump up and down. HTML and CSS is taking the spotlight, but JavaScript always has the back. So JavaScript in the back is allowing the button to move, but no credit is given to JavaScript. So HTML and CSS, they're spotlight people, just like us when we move around, you see your body moving, my hands is moving all over the place. My muscle is not getting any credit, but the muscle is allowing me to do all of this. But in the back, just watch it come alive, right? So I wanted to move forward 4 times. So 1, 2, 3, 4, right? So I'll create a for loop and put it inside of a loop. So I'm not going to get into the depth of each of the looping process. I just want you guys to understand loop, right? So just going to create asterisks here so we can identify the different types of loops. There might be more, but these are the mainly used ones, right? What we'll do now, we'll just probably say loop 4 times. So create another loop function and put a 4 inside of it, and then put it inside of this loop function. So ideally, what we're telling the move forward function to do is what we're telling the robot to do is move forward 4 times, right? So we go inside the loop, so we hit this loop, we hit the move forward function, the robot moves 1 step, we go inside the loop again 1 more time, so that is 1 iteration. That is why they call it iteration, because iterating, loop in the process. We go inside the function again, we move forward 1 more time, we loop, right? Move forward again, we go inside the function, move forward, and loop 1 more time, and it moves forward. Then we loop 1 more time, and it goes here. So we're at a blockers now. This is blocking the robot. So the robot is moving forward, but it doesn't know where to go if there's a blockage, right? We're trying to create things that works on its own. You know, the tracks will never always be the same, right? So here we can introduce conditional statements. So if the robot is to come to a dead end, what should it do? Right? So there's always moving forward, there's always moving left, there's always moving right, there's always moving backwards. Right? So working with the 4 cardinal point, not so east west, right? So if the robot comes to a block, we can write that as well in programming. So these are what we call conditioning. So if the robot comes to a block, so if I'll just say block for now, right? If block, if blocked, right? It's just another function as well inside the function. So if blocked, right? Then what do we want the robot to do? And remember, we're building for the future. We're not building things that just work off this track. We want the robot to thrive on many tracks. And we're going to create this code and then we're going to change the track and we'll still see if our robot can navigate the territory, right? So if blocked, then I want you to go right or left because if you're moving forward and there's no way forward, it's either you go left Sorry, as I go left, I go right, right? So if blocked, I want it to turn right, right? So just going to call turn right inside of this as another function, right? So I want it to turn right, but maybe right isn't the only direction, or right isn't the right direction. Maybe there's a left option. Remember, we're not building for this track alone. We're creating for many other tracks, and we see how our algorithm comes to life in another track, right? So we're instructing the robot to, when come to a block, you consider the option to go right or left, right? So if there's a block, you turn right. But if turn right don't work, turn left. So in programming world, they call it an else, right? So if it doesn't work, else do the next thing. So in a sense, that is how it reads weird in English terms, but if you haven't achieved this particular goal, then consider something else. So let's use then for now, but else is the correct term. But if this doesn't work, then do something else. So if you turn right, right, and you start to move forward and you come to another block, consider left, right? So let's use then or else if it doesn't work. Else, if turn right doesn't work, then turn left. And like I said, this is very high level. Yeah. Privately. Oh, sure. All right, give me 1 second, guys. Yeah, bro. Yeah, that's what I'm saying. We're playing. Yeah. I know, it gets deeper, it gets deeper. So, what Roxanne was saying is she was basically saying she was taking semantics into consideration. If it turns right, the robot turns right, you'll have to turn the other side and turn to go up. So there's a lot of concept, but I want it to be very simplified. If you're blocked, turn left or right. So we're not considering the robot's rotation, right? I want the concept to be grasped. Like I said, the concept is what we're after, right? So if you're blocked, then turn right. Else, if this if statement doesn't work, try the next thing, which is turn left, right? Right. So if my robot is to move forward, 1, 2, 3, 4 through this loop, so I'm looping it, 1, 2, 3, 4, comes to a block. So this there's already a program here. So the robot in itself will check back to the algorithm to say, all right, so I'm at a block. What do I do? Right? You already given the instruction. You already writing instruction on how the robot can navigate its territory. So if I am blocked as the robot, which I am right now, what should I do? You've created these series of steps to give to the robot now. So I can choose to turn right. So let me attempt as a robot to turn right. So I move 1, 2, 3, 4 forward, turn right, and I turn right and check. There is no block, so I should probably move forward again, right? So here, because we move forward 4 times here, we want to loop it again here because remember, it's a linear set of steps that we're giving the robot to do. And the program and the computer doesn't work any different. It's the same fundamental concept. So now that we're turning right with the robot, we need to move forward 1, 2, 3, 4 times again. So we'll create another loop, right? So loop how many times? 1, 2, 3, 4 times again, right? And you can see where we're starting to repeat ourselves, but we get into that once we finish algorithm. Let's get through it first, right? So I want to loop 4 times the move forward function because we've already defined it, we've already created it. So I want to loop it 4 times. Right? So if I loop it 4 times, I know for sure that my robot will, starting with the for loop, which I'll break out into, I'll just group them into what does what, right? Using this triangular looking thing. So moving forward now, 4 times, 1, 2, 3, 4. It's at another block again. However, we've already compiled the code to do that thing already. So it checks back with the programmer to say, if I'm blocked, what do I do? Turn right or turn left? So I'm moving forward. I can choose to turn right as the robot knows. So if I turn right, right, there is a block. So I call it if blocked again, right? I turn right, right don't work. But I realize there's an else case just in case the if doesn't work, right? So else, if right doesn't work, you're going to turn left. So the robot knows to turn left, and then in turning left now, we need to define another set of moving forward. So 1, 2, 3, 4, 5. So create another loop again that says loop 5 times or iterate 5 times the move forward process. And that should do it, right? So let's test this algorithm that we just created for this specific map on any other track to see if it actually works, right? So we're just going to erase this. The robot is still there. However, we're creating this intelligent being or this intelligent bot that can operate in a space on its own. We don't need to instruct it continuously on what to do, right? It already has a series of instructions, and we're testing this algorithm to see if maybe we can refine it some more. So let's go. All right, so I'm just going to create a random track. Random track is a more complex track now, right? So the robot is learning, it's getting smarter. We're testing its ability to grasp the algorithm that was programmed into it. All right, so we have a complete different track as we know. We see it and we're defining the steps. So the steps are represented by these squares. Let me just show you how interesting this can be. Just drawing some squares. Some of them might not look like squares. Let's switch it up a little and see what happens. Let's go this direction instead of it here. And boom, squares, squares, more squares. These are squares, by the way, guys. There is the laziness. All right, so we have a very complex roadmap here. So remember before we just had boom, 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 and I get there. So let's see if our robot can navigate the territory. So inside my code, me as a robot is instructed to move forward, right? So I'm going to move forward 4 times. 1, 2, 3, 4. So I'm going to be blocked. So everything is going to be a bit chaotic for me as a robot. So 1, 2, 3, 4, and I keep hitting and I keep hitting. But I was already instructed to go 4 times. So I'm going to just attempt to go 4, but I can only achieve 2. So in my blockage now, I can check to see if I'm blocked as a robot, right? If I'm blocked, what should I do? I'm going to turn right. So let me attempt to turn right first. Right seems to work. Just going to move forward again. 1, 2, right? Move forward is another command that I can check with to see that I have a move forward instruction. And then if I'm blocked again, I can choose to turn right. Turn right would work because turn right will bring me into the corner here. And I can choose to turn left, right? So the turn left allow me to turn left, right? And then in turning left, I can check with the move forward function to move forward again. So 1, 2, blockage again, turn right. And you're seeing that it's just referencing the series or the set of instruction that is given to it to achieve a particular task until it eventually gets to that point. So it knows what happens whenever it comes to a block. It knows how to move forward, it knows how to move left, and it knows how to move right. So in a sense, that's how a typical robot would work, and that is how a computer works. You give it a series of instructions, and it receives and executes on it. However, let's clean up things a little, right? Because we find that we're looping through things. We're giving it specific instruction to loop through 4 times when there are certain tracks that allows it to move forward. Only 2, right? So, okay, all right, perfect. All right, so we need to clean up things a little because we find that the move forward function, though it's looped, it's called all over the place, right? Maybe we want to create something more sophisticated that doesn't depend on loops. It only depends on that raw function, on what a move forward command is, right? So here's what we'll do. We're going to just erase our algorithm that we created previously, just to clean up things a little. We have the block function, and we have the move forward function, right? So with programming, a lot of this is what you call refactoring. So you're refactoring the code to be more efficient, to work better. So maybe in the move forward function, we can define something that allows it to just move forward, period, as opposed to instructing how many steps to take. We just want to have a function that allows it to move forward, and if there's a blockage, consider right or left. So I'm just going to say if you're blocked, right, then consider right, or I'll just use or instead of else, just so we can be on the same page, or left, right? But we also want to consider as well what happens when it turns right or left, right? When it turns right, so if right works, if there's no block where when it turns right, then you move forward again. So the essence of it is now, we're going to say now, if, create another if. So there's a lot of if statements in programming, by the way. They've come up with more efficient ways to maneuver this, but you'll learn that as you go along. So if right, so if you actually turn right, then I want you to continue to move forward. Right? And if you're attempting to move forward and it doesn't work, then if right, move forward. And if left, move forward. So you have something that you can write or as well. So if right or left, just to save time, right? And space. If right or left, then move forward. So every time you turn right and every time you turn left, attempt to move forward. I already have something that is considering or accounting for the blockage. So here we go now. So we have a function defined, it's much more cleaner, it's a little more intelligent, right? So we have a move forward function. So I as a robot, I'm going to attempt to move forward infinitely because we define our function to do such. So moving forward, I'm just going to continue to move forward. If I'm blocked, which is at the end of this stretch, I can turn right or turn left. So I'm going to turn right first. So turning right. When I turn right, what am I supposed to do? So if the robot turn right or left, we want it to move forward. So when I turn right or left, I turn right, I'm going to move forward, right? Then I come to another block. I reference my algorithm again to say, if I'm blocked, turn right or turn left. Let me attempt to turn right. It seems to work. I'm going to move forward. And the series continue until it makes its way. But let's just go a bit further to see what really happens, right? Move forward, turn left, turn right, move forward, turn left, turn right, move forward, turn left, turn right, move forward, turn left or right, move forward, and turn left or right, move forward, and then turn left. There will be a block up. You turn right, there's still a block up. So here it will be interesting, right? So I'm blocked here as a robot, but I'm still in a forward moving position. So there's still right and there's still left. So I'm just going to turn right as the robot and just move forward to the end. So we'll find that this algorithm seems to be a nice mapping for any robot to work in any situation. Let's test it again in another situation. Just a small example this time.
I have a question.
Sure.
Okay, looking at the loop, is it that the computer will always know to go back to the starting point to attempt the turn? If you know what I'm saying. So like if it is that I attempt to turn right and I'm blocked, I know to now go back to the starting point and then attempt a left turn.
All right. So there are two ways to write this. So all right, so there are two types of programming, right? There's sequential programming and there's a type of programming that they call like a method type of programming. So it's like for series, it's like you have to account for every single step of the way, right? So it won't have a reference point to go back to find that thing in the algorithm to execute on. You literally have to define that path every step of the way. So every step must be accounted for. So that's a very good question that you asked. But what we're doing now is more of a method type programming where everything isn't run in sequence, right? Everything is just run whenever it's needed. So everything is segmented off to its own doing, and whenever it's needed, the program can reference or the computer can reference that specific function to execute on it. So the old way of doing things is sequential programming, where everything must be defined. There was no intelligence to it. there was no way to reference things back. There's always just everything must be accounted for. So this terrain that we're defining, the set of steps, every single step must be accounted for. But this is the programming for the future where everything is just needed when it's needed. Everything is executed on when it's needed. So it's more of like a object oriented. It keeps everything encompassed into its specific use case or need. I don't know if that was clear. Was that clear, Cassie?
Yeah, it was. Thank you.
Yeah, man, no problem. So back in the days, so I want to address. So once we tell the AI to move left or right, does Joel have a question? Let me just verify. Right, that is correct, Joel. So that's the idea. So we already account for all the scenarios that could possibly happen as the robot navigates the territory. Therefore, it will know that that intelligence exists. So this is the concept that they apply for AI. So AI, it just referencing exactly what it needs when it needs it. The robot is smart enough to know what function or what method to call, and that is the fundamentals of that. All right. So in my definition, right, there usually has to be something that is much more complex, but I don't want to get into too complex. I just want you guys to understand what functions are. So behind the scenes of this move forward function is a lot of other code telling it how to move forward, how to move the legs, how to visualize things ahead of him, and such and so forth. But like I said, this is a fundamentals class. You just need to know that functions are action giving um, states, sentences or statements or right action giving words, and you can in functions or methods you can create your own methods or functions, or you can use the default out of the box program or methods or functions that come with a specific programming language. So let me give you an example of something that might come out of a programming language. So we want to print something on screen, so moving away from robotics a little, right? We're going to go get more intimate with the program itself, with a computer itself, right? Say I want to print something on screen. What I'll probably think is I just need to write print whatever message I want on screen. So let's say print hello world. So this is one of the most popular terms in programming because if you start in any programming course, they always bombard you with hello worlds, right? It's the first thing to get your program or get your computer to respond to a message that is injected inside of it. So if I want to write print hello world in different programming language, let me show you how the syntax may vary. However, at the end of the day, what we're trying to do is just print hello world, right? So for Java, I don't know if you guys are familiar with these languages. These are different programming languages. For Java, you have system dot out dot print line, right? Print ln is already defined, and then inside of this, you put the hello world. Right? In Python, you'll have print inside of their hello world. In JavaScript, you have console.log hello world. Right? So these are some examples of how different language will achieve the same exact goal, right? So we're trying to print hello world on screen. However, Java will have its weird way of doing it, using its own syntax. Python or many other languages, C uses this as well, C++ uses this as well, and C sharp to a less extent. So let's just use Python for now, right? So Python is another language. And then console.log is a JavaScript specific sets of function. So this is to say that there's always this ongoing debate. I mean, like you guys are starting programming now, and you guys are going to get bombarded with a series of questions like, why do you use JavaScript? Why don't you just use PHP? Why don't you just use Java? Why don't you just use... The conversation goes on about what language you should pick to do anything at all. I would say, guys, you can use JavaScript to do anything. You can use Java to do anything. You can use Python to do anything. You can use PHP to do anything. The idea here is we're trying to print hello world on screen. But which of these syntax flow better with your English vocabulary? Does print sound more appropriate? Does console.log sound more appropriate? Does system out.println sounds more flowy to you? Just pick one, right? The essence of it is pick a language that can achieve the goals of what you're trying to achieve. And then as you go along, you're becoming a master at it, then you can build anything. So let me tell you why I want to introduce you guys to JavaScript. This is not a sell, right? But it is a sell, right? So let's take a seat with this one. So JavaScript is the language of the web. And don't make anybody tell you otherwise, right? People come to you about PHP, I'm joking. It's a very biased thing I'm going to say to you guys. So JavaScript, 70% of the web is JavaScript. You can write HTML using JavaScript, meaning you can build an entire website using just JavaScript, no HTML, no CSS. JavaScript, I use JavaScript to create mobile apps. So the apps I've created, I've used JavaScript to build them. Websites, JavaScript. Desktop application, JavaScript. My backend servers, JavaScript. Something to power Raspberry Pi. I don't know if you guys are familiar with Raspberry Pi, microcomputer, Arduino, JavaScript. It's just for me, it's one of the most powerful languages and it's ever growing. The most popular used front-end framework, and framework is just it's a compiled version of a language. So many languages have their different frameworks. So JavaScript have a series of frameworks like Angular, you have React JS, you have Vue.js, just to name a few, Ember.js. So frameworks in itself make mundane tasks much more streamlined and easier. So as you can see, it's a very powerful thing, and one of the most popular used front-end frameworks to date is built in JavaScript. So Angular, you can research that. Vue.js, I remember the guy that started Vue.js. He got popular, I think, in Korea, one of those Asian countries. He became a superstar because he created a JavaScript framework. That is Vue.js, right? All right, hold on. Somebody have a question. So what the engine used the JavaScript on? Still Visual Studio. So, all right, so Visual Studio is an editor, Joel, right? So to answer, for everybody to have an understanding of what Joel's question was, he was asking what engine he used to write JavaScript. Is it still Visual Studio? So Visual Studio is an editor. This is where you write a series of instructions. The engine that powers JavaScript is something that you call probably a V8 engine. So V8 engine is what Chrome uses to power JavaScript. And every time you see there is a new function available for JavaScript, is the V8 engine getting better to accommodate it. So I don't know if you guys remember our first class when we had expressed that the browsers back in the days can't do what they can do today. So back in the days, there was no if we open a regular HTML document and present it. So if they're getting more advanced into what they can support, you need to refine the browser and the engine, right? Which is, like I said, the V8 engine. Firefox uses Thunderbird engine. Each of them have a different name, right? The browser Edge uses another engine. You can do the research. If you type in the engine for the specific browsers, you'll see the names of them coming up, just listed there. So in essence, just to get back to my point, I choose JavaScript because it's one of the it's the most popular programming language, and JavaScript has been there from the inception of wanting to make functionality for website easier, and it has been maturing as time progresses as well. So a point I want to touch on is JavaScript had a poor start, right? It had a start where the community, everybody was like, why this alphabet so difficult? Because trust me, there's a lot of convoluted processes, right? So they created many things on top of it. So you come up with Ajax. Ajax is another step up from plain old JavaScript, as they call it. You have Angular, which, as I stated before, remove some of the complexities of JavaScript to make it a more simplified process. And then JavaScript doesn't support type, which we'll get into as the next topic. So type safety is very important in programming, right? Programming allows you to define a set of variables and you want to observe a certain set of standards. That is why typing is so important. So JavaScript by itself does not support type. However, they created something called TypeScript that allows for JavaScript to support type. Let me just show you what types of things are, or types of variables or programming terms are, right? So in programming, we've also decided that we wanted to print something called hello world. So in programming jargons, hello world in itself will be represented as a string, right? And each individual letter is represented as a character. So these are types defining what can be what. So I'll just leave this example because I'm going to go back to it, but I'm going to introduce you guys to types. So the different types that are supported are, you have string, you have number, you have boolean, you have decimal, and many other, but these are the main ones you will actually use on a day-to-day. So as I was saying before, strings are usually represented by words. So inside this, you have a string, right? And a string is represented using these notations. So hello world is a string. A number, we all know what a number is. 1 to 10, or 1 to 9, sorry. Anything that is represented from 1 to 9 is a number. Boolean is true or false. So is this thing true or false? So going back to our previous example, saying if it is blocked. So if blocked is true, which is a Boolean, then do this series of tags, right? Decimal is anything that is not from 1 to 9, anything that follows the point. So a 0.9 would be a decimal. The reason why these things were created or types were introduced into programming is because there are certain rules that must be enforced. You don't want people to be entering a text inside of a password field. You want it to represent that block up that series of dots that represent each character that's been entered, right? So it basically enforces certain acceptance criteria when writing programs. And let me show you how this can really come to life. So let's say the print function, you're creating the print function, right? You only wanted to accept a string, but somebody attempts to enter a number. The computer in itself will break and start to complain that my print function does not accept a number, only a string, right? So it allows you to define certain set of steps because we're dealing with people and rules were created for a reason. It was created for persons who attempt to break the law, right? So create rules to prevent them from breaking the law. So that is what data types allow you to do. It allows you to define the law or define a certain set of rules that is abided by whenever you're writing something. So in summary, right, the things that you need to worry yourself about, we have to write code for you guys to appreciate what variables and such are. You leave. Alright. You go for the kingdom? What time are you for that? Oh, is that? Oh, sorry. Oh, okay, all right. So I need to go around my computer for you guys to appreciate the different aspects of programming. So, like we mentioned functions, we mentioned iterations, we mentioned conditions, we mentioned data types, and these are the fundamentals of every single language you come across. Trust me, at least 90% of it. Um, Give me a second. I'm just going for a charger for my laptop so I can do it there. All right, so Dre decided to get it for me, right? All right, so without further ado, I'm just going to share my screen. So, like I said, I don't like to repeat things. Everything is on the web already. Everything that you need to know is on the web. It's just knowing how to navigate. So, if I give you your paintbrush, you should know how to stroke the brush to paint flawlessly, right? So, I'm just going to hand you the brush by sharing my screen for you guys to have a proper appreciation of JavaScript. So I'm using JavaScript because, as I stated before, I'm a personal bias for it, and it's a beautiful language, a language that I've created everything in. I can create things down to a micro level and things to a magnified level, right? So just confirm that everybody's seeing my screen. What I'll do is I'll go to W3 Schools. Every three schools, man, this is where I grasp a lot of things because it just gives you everything to play with. You don't have to power on a JavaScript engine. You can literally come here and it tells you a series of things that you can achieve. So to the left hand side, which is just the list of options or menu items, this encompasses everything that you'll ever learn in any programming language, period. So at the left, you see variables, you see arithmetics, which is mathematical equations and formula. You have operators, which is similar to arithmetics. Data types, which is the string, boolean that we'll go through as well. You have string, this is narrowing into different functions associated with strings. String methods, which is fundamentally the same. Array is a collection of items. And this is how I'll just go through this JavaScript because I think you'll have a better appreciation if you do it this way as opposed to being on the board. You have loop, for loop, you have a while loop, you have break, you have regular expression. Regular expression is basically something that allows you to predict text or account for many scenarios without writing strict code. So you can identify a string that has 20 characters every single time using regular expression. Errors, how to handle errors whenever the computer come up on a blocker. Let these are different words or terms used to define the different types of variables, arrow functions, and we'll get into the other things, right? So for starters, big introductory term, JavaScript is the world's most popular programming language. Hands down, if you look it up, JavaScript will always come up on your search every day of the week. And it being the most popular, it allows you to get a lot of help from the community. So it has a big community. And this popularity is determined by the community, the number of persons using it. It's the programming language of the web. They say the same thing about PHP and many other languages. This is a bias statement, right? But it is, in fact, like 70 to 90% of the web is powered using JavaScript. JavaScript is easy to learn, I agree. The tutor will teach JavaScript from basic to advanced. So I wanted to just show you guys how it fits into the equation. And like I said, the only way for me to do this is not on the board, but actually on some code and on the computer. So the first example here, it's saying click me to display date and time. So in clicking that, you see date and time appears here, right? JavaScript allows you to do that. HTML can't allow you to do that, and CSS can't allow you to do that either. So let's try it for ourselves and see what's happening, right? This is where the beauty is being demonstrated. And I'll walk you guys through what everything represents, just so you guys can get a grasp of what was being what was being taught in the fundamentals and how it applies to here. So here we still have HTML code. We still have HTML code. This is something we're all familiar with already. However, you're seeing that there are different introduction of attributes. So we had type, remember we had class, we have ID, and a few other things. The type defines it as a button, right? It's just telling it exactly what type of element it is, what type of HTML element it is. However, JavaScript is introduced on this onClick attribute to achieve a particular set of tasks. So let me just explain what is happening here. So I remember I expressed before that IDs are important, right? And this is the very reason why it's important. So for IDs, each element should have a unique identification, identifier. Let's zoom in on my screen a little so for person can see clearly. Each element must have a unique ID, and this is why it must have a unique ID. So if we're going into JavaScript now, right? We want what it's asking for happen here is whenever I click this button, I want it to display some message in this paragraph. So let me show you how JavaScript get that done. It's English and I just spoke to you English. So whenever I click this button, I want my day to show here. So in walking through, document is a reference to the entire website. JavaScript has this pattern and it sticks with this pattern. The document, it always starts with a document. So the document, remember we said HTML in itself is a document, right? So JavaScript needs to know that, or the computer needs to know, or the browser needs to know that it's referencing a document. And this is default, right? And then the dot inside this document, there is another function that says get element by ID. So this speaks for itself. It's English. We're trying to get a HTML element by its ID, right? So inside of this function, it accepts the ID for that element. So we're looking on the entire document to see if there is an ID that is called demo. right? And then inner HTML represents what happens inside of the HTML tag. So what happens inside of here, right? So like I said, these are those jargons once you grasp the fundamentals, which is document dot. Document consists of everything. Everything that JavaScript will need, it comes from document. So get class, which is probably a class as opposed to ID. Get something else. Get a type, right? You can define them from the document. So JavaScript in itself starts with document. So what this is saying again is on clicking this button, reference the document, and in that document, I want to get the element by the ID, and inside the ID or inside the element, I want it to display the date. So date in itself, right? Date is a function by default in JavaScript that allows you to pull the most up-to-date things. So if I click this, now it's saying 36, it will say 37, right? All right, so the time will always change as you click. Every time I click, I see the seconds running because JavaScript has the power to pull from the site. This date function was created to get the most up-to-date time on your computer. So we're seeing that it allows you to do some powerful things out of the box, without getting your hands too dirty. This is HTML that you're familiar with, but JavaScript just fits itself closely in line, just like CSS did. So CSS, we would have used something like this. Like probably say style equals color ref. So we're seeing that the fundamentals is the same, but JavaScript have it as its own way of referencing things. They have an on-click function, on-click attribute, sorry, and it has many others as you learn as you go along. Style, CSS reference, on-click, JavaScript reference. So you can't put CSS inside of an on-click. So those are the simple rules that you need to abide by. But the fundamentals of JavaScript, we're referencing the document, which is the entire website, which is an HTML document. And you want to get something on the page and you want to do something with it. So whenever it's clicked, I want to get this element on inside of this HTML document. And inside of the element, I want to put the date. And that is what that is doing fundamentally. I'll go through some more examples so you guys can grasp the similarities. All right, so just scrolling through the example, scrolling through the examples. So going through the introductions. So this page contains some example of what JavaScript can do, right? JavaScript can change HTML content. And we already spoke about the inner HTML. So I tell you guys, you can create a website using JavaScript. And I'll show you what that looks like in an example as well. So as they express in here, the example below finds an HTML element with ID equal demo and changes the element content to hello JavaScript. Let's look at the example again, right? So we have the paragraph tag, which we're all familiar with. This is still HTML, guys. But what we want is for a user to have an interactive site where when they click this, it changes the hello JavaScript. We can change this to Nyla just for appreciation. But just to understand how things are read. So this in itself is a website. This is an element, right? Or this is a document, sorry. So on click of this button, I want to reference the entire document, and in that entire document, I want to get the element by ID, which is the demo. So let's look inside our HTML code and we realize that there's actually an element called demo, right? And then in that demo now, I want to change the inner HTML, which is this code or this sentence to this sentence, right? So I'm just going to click the button and pay attention to here. Let me zoom in again. So when I click this, it's supposed to change the hello Nyla. So click. Oh wait, I never run it, sorry. When I click, it's supposed to run hello Nyla. So we're seeing where things become dynamic using JavaScript. So it's giving the functionalities to buttons. So buttons can now perform specific tasks, right? So before JavaScript, the buttons were useless. You couldn't use it to do anything but reference a button. But JavaScript gives it that power. And this is just a very lightweight example of what JavaScript is capable of doing. Let's go a little deeper, right? So I already went through this example, which is similar, right? Look at this light bulb now. Here is where things get fun. So let's turn on the light and let's turn off the light. JavaScript allows the bulb to light up, but there's a fascinating way of getting this done, right? Only thing that is happening here, when I press turn on, it changes the image to one that is lighted up or lit up, right? And when you turn it off, it changes it back to one that is off. So let me try it. Let's try it ourselves to see what is really happening here. So things we're already familiar with HTML stuff, right? Here we're seeing that on the button click, which we've been done saying already. So unclicking this button, because we do click the button, right? Get inside the document. Let me zoom in just so we can see clearer. You're going to get the element by the ID. So we're looking inside the entire document to find an ID that says my image. So let's look inside here and let's see. All right, boom. This image tag, right? It has an ID of my image, which is what we're looking for. And we're seeing that the source is when the bulb is off. So this image is representing the off image or the off button or the off bulb, right? They style it with some CSS, something we're already familiar with, right? So we know that inside our document, we're trying to get the element by ID, which is my image, which is the image, which is this bulb, and we're trying to change the source. So we're seeing that inside, so getting the element, we're getting this entire thing, which we're already familiar with, guys. Remember, image is an element, a HTML element. I want to get the element, and then when I get the element, I then have access to these specific attributes inside the elements. I can choose to change the style, I can choose to change the source of where the image lives or where it's coming from, or I can choose to change the ID if I want. But what we're seeing here is we got the element. Now we're trying to reference the source. So we use dot source. So we're trying to get this, and then we change it to on, right? So we're realizing that pick underscore bulb, this is just the name of a file. Don't be bombarded by this. This is just the name of a file. And a .gif file is similar to .png or something you're more familiar with, .jpeg. Just don't be bombarded. This is just the name of a file or the name of an image, right? So, but what we realize here is the on is what represents the status of the bulb. So this is just the name to identify this is the off bulb and this is the on bulb. So we're going to change this source, which is here, to an on bulb, right? Because we want it to light up whenever we click it, right? So let's see what happens again. Let's run the example and see what happens. So this is for the turn on the light button. And in writing turn on the light, we can change it to anything. We can say turn the Nyla light on, right? And we'll see how it affects the name of the button when you run it. So turn the Nyla light on. So this in itself is just HTML code, but JavaScript allows this beautiful functionality to change whenever I click this button. So on click, I want it to change to this image, the on bulb on, right? Let me just inspect. Sorry, I was doing some development last night. So I just wanted to go to where the button lives. Sorry, bear with me. Clicking here, hover over. So W3 schools slash JS slash pick gift, right? So just going to copy and paste this. What I'm going to do, I'm trying to reference the image so you guys can see that's the actual image being referenced, right? So pick underscore bulb on dot gif. So pick underscore bulb on dot gif, I think. All right, nice. So what we're seeing is it's a typical image. It's just an image, and the same for off. Let me just copy this and reference the image as well. So just going to change the on to off. And this can be any name, guys. So if I download this, if I'm to save this image to my computer, I would have it as pick bulb off. Maybe I want to make it a little less complex by saying as bulb off. So this name is a variable, it's dynamic, it can change, but these are the things that confuse people in programming all the time. Being able to differentiate what are actual constructs and what are variables. Variables is man-made, variables is us giving our own name to things. So this is what exactly what they do with the pick of the bulb. So we're seeing that bulb off is an off bulb and bulb on is an on bulb, right? So in essence, what they're doing here, just to go back to the example, let me just refresh that because it took a responsive thing. So in essence, just in summary, we're referencing the entire HTML document. We're trying to get an element, an HTML element by ID of my name. So my name is an image, right? And then I'm trying to change the source from off to on. And then it's the same for this button that turns off the light, right? Once the light is already off, it's always referencing the off GIF or the off picture. So here we have a button that says reference a document. We're going to get the element by ID, which is the image element. and we're going to change the source to an off bulb, right? So when I click off, it's supposed to change to this image. So what has been happening? The very same thing as they described it. So all we're doing here, guys, we're just referencing the entire document, and we're trying to find specific elements to perform specific actions to them. So let me go for something that is, let me break this side for a second, right? So I'm going to show you how we can break things a little. So let's say we want to remove the source. We don't want it to show any picture at all. We're going to break things. We're just going to remove the bulb totally when we press turn off, right? So let's run this. Turn on the light. Light has been turned off. And if I turn it off, the image has been removed totally because we've removed the source from it. So we just basically make the source blank. So there will be no image, right? And just to go back to the example and run it again, turn on and turn off. But what we're trying to do is we're just changing the name of the source tag that is being referenced. Remove that, turn it on. Well, let me run it first. Turn it on and it's removed totally. So that in itself, like I said, is just a document reference. And JavaScript as I said is just unique syntax that allows it to perform a series of tasks. Let's move on to another example, right? So what it is saying here as well, JavaScript can change HTML styles, which is CSS. So this is where things get a little bit more interesting, guys. So remember, we stated before just now that zooming in on the screen, this is kind of tacky for me. Let me just give some more space to the text because this is what's really important. All right, so JavaScript again, like I said, reference the entire document. It gets the element by ID, which is demo. So demo here, this paragraph tag that is the ID of demo. And it wants to change the style, right? So remember we were saying that once it gets a hold of this entire element, again, it can access the different attributes. So let's pretend that there's a style tag inside of here that has a font size, right, of 40 pixels. And let's make it extremely big, 100 pixels, right? And this is just me confirming that font size is actually the way to write it in CSS, right? So font size, just ensure I have the right syntax. So like I said, this is all syntax, but I know I want to just change the font size, right? So paste is here. We're going to make it a very big text. So 1000, right? And we're going to run it. It's kind of huge. Oh wait, ooh, it's kind of massive. Let me just get in on that. So it's very big, right? It's a very, very big font. So in essence, what we're doing here, guys, is we're referencing this style attribute and we're changing the font size to a smaller size whenever we click this button, right? So this wasn't here before, but it shows how JavaScript can just reference things or give it a value without it being present. But I put it here so you guys can have a better appreciation of what is really going down here. So we're going to change this big text over here to a smaller text whenever we click this button. All right, we're already familiar with onClick. We're just referencing the entire document to find an element by ID, which is a HTML element, which is called demo. And we're changing the style, more particular, the font size to 35, right? So let me zoom down to the click button. Let me see if I can find it in this clutter. It's very huge text. Scrolling down, all right, click me, nice. So when I click this button, this font size of 1000 pixel is supposed to change to a nice 35 pixel. Let's see. Click here, boom. Now we see our fonts change, right? To a smaller font, it's more readable, it's 35. Maybe we want to make it a little bigger. Let's change this 35 to a 60 and run and let's see what happens, right? Let me just reduce this a little so you guys can actually see the font size being changed. Let's make it a very small pixel. Run it. All right, so we'll see that it's very small. It's 12 pixels, nice. But we wanted to make it bigger whenever we click this. So click it, boom. JavaScript and style. So we're changing up the style using JavaScript. And this is where I'm showing where JavaScript is so powerful that you can manipulate styles, you can manipulate the HTML themselves using JavaScript. So it commands the web, it commands the document, and it takes it as its own, right? So in summary for this particular example is document. Remember, we reference the entire HTML document. We're JavaScript in itself is always trying to locate something inside the HTML code, right? And when it locates it, it attempts to get it by class or get it by ID, just to name a few things, by whatever attribute is here, and use demo, which is the ID name, right? And you're trying to change the style tag into something more readable, right? All right, so moving on to another example. And you'll see, but as we do more examples, as I said, programming is a lot of practice as well, I guess. As we do more examples, you start to see some similarity. You start to see what is syntax and what are variables, right? So JavaScript can hide HTML element. We already showed this as well. So let's try this one in particular again. So let's zoom in on the screen one more time. So unclicking this button, right? And unclick, guys, remember, it can't be unclick or anything you feel like it being. These are mandatory things, right? This is not a variable. This is a construct. Just like ID can be identification. It has to be ID. So these are things that you need to familiarize yourself with. It has to maintain the same name because the button only knows the attribute of unclicked, not unclicked, not anything you want it to be. It observes certain protocols and standards that are already driven into it. So unclick will never change. Unclick will always be unclick, right? So unclicking in the clicking of this button, I want to reference the entire document and I want to locate an element that is called demo, right? Let's see if there's a demo element, right? It's right here. And we're trying to change the style and we want the display in particular to be none, which is ideally hiding the element. So let's say we're playing a game and or we're building a website and we want somebody to just interact with it to do different functionalities. Let's see what happens whenever I click the button. I click it and it hides this one because we did change the display to none. But let's switch up the script a little. Let's refresh this page a little. And we want, instead of this paragraph having the ID, I want the H2 tag to have the ID because I want to hide the H2 tag instead of the paragraph. So let me run this and let me click it. Boom, it removes this H2 tag because this functionality now holds the ID of demo. I change the style from display to none, which ideally removes the JavaScript from the page. So we're seeing that these are built-in functions by JavaScript. As I told you before, as we were demonstrating with the robot, move forward was a function, get element by ID is a function. And in the back of this, there's a lot of other things happening where there's a locator parsing the entire site or parsing the entire HTML code to find this demo ID. So you don't need to worry yourself about these complex things. You don't need to worry yourself about what really goes on. All you need to know is how to use it. I know I want to get the element by ID. Somebody has already created a get the element by ID in JavaScript construct for me to use. So I capitalize on it and I just tap into those resources. All right, so let's move on to another example. So we don't necessarily need to show the HTML tag. We already know how to do that. In a sense, it's fundamentally the same. The CSS changing some styles. Let's move on to another topic. So they're basically, I remember Joel was asking a question, right? How do you fit JavaScript into your project? Where does it live? So remember CSS, they constructed a script, they had a style tag. In JavaScript, they actually have a script tag to represent JavaScript in itself. So we can use Visual Studio Code to write it out just for a better appreciation. But let's just use this because fundamentally, this is an editor just like Visual Studio Code. I'm just not writing it inside my Visual Studio Code. I'll bring up Visual Studio Code so you guys can get a taste of how it's introduced into things. Sorry, this is a lot more. This is a complex project. Close, close. So, don't pay attention to this. Don't pay attention to this. It's a false panic. All right, so I'm just going to create another folder called Nyla JavaScript. All right, I'm going to create things here, and yeah. So I just want to open this folder inside my Visual Studio Code. So remember, guys, Visual Studio Code, along with many others like Atom, Code Blocks, they're just editors. It's where you write the code. Visual Studio Code is very powerful. I remember having a conversation today with, well, this morning with, I don't want to misstate the name, with Mr. Palmer, Dr. Palmer, right? I was having a conversation earlier and he was asking how to run code. And it's funny that he should say that because we haven't gotten to a point where we need to run anything. Everything is just double click and go. However, it was an interesting question because inside of this Visual Studio Code, there's a terminal. I don't know if you guys are familiar with terminals, but this is a introduction to CLI, just so you get an appreciation of what's to come. CLI, in essence, is writing a series of commands inside of a terminal that the computer can spit out certain results. So let's say I want to view the IP address of a specific router that I'm on, right? I can write ifconfig enter, and I get a bunch of commands highlighting the IP address and different things that I need to access. In the command line, it allows me to do another series of things. So maybe I want to do a print. If it's false, if it doesn't work, it tells me. But I can write scripts or commands to run my code. But when we get to that point, we'll be using command line to do a lot of project scaffolding, and scaffolding in itself is just creating things outside the box. So I'm gonna just give you guys an example. Bear with me here, right? So Ionic is one of the frameworks that I use. Not to stray from topic, but I just want you guys to get a feel of what is to come. So Ionic, you guys can check it out. It's not on the class curriculum for today. However, it's something that we'll deep dive into later on, right? Ionic in itself, Ionic framework is a community of mobile developers, right? They created a platform that allows you to simply create a mobile app, right? And if I want to start a brand new Ionic project, using my command line, I can write Ionic start, right? When I press Ionic start and enter, I go through a series of things which framework that I want to use, React or Angular. I use Angular. I want to give it a name, so I'll call it Nyla, right? And I go through which default thing I want to start from. Maybe I want it to have tabs, right? Enter, and it does everything automatically. No automatically before you run that series of command. And if you look to the top left hand corner here, you realize that it created a Nyla folder with a bunch of folders inside there. And all I was doing is writing a series of command. So it has the HTML files in there, it has CSS files in there, TypeScript files in there. So it generates automatically for you, so you don't have to do the hard work. So I'm going to show you what I just created using three commands. So command line in itself gives you that power to just scaffold brand new projects off the bat that has all the fundamentals or the foundation of what you want to start. Sorry to stray from topic, but I figure once I introduced it, for you guys to just see it in its entirety, I had to do this example quickly. So right now what it's doing now is pulling all the dependencies. Don't worry about those errors, still pulling more dependencies. And do I want to create an account? No. So I'm interacting with my terminal. It's creating a lot of things here. So, but let me show you exactly what it just did, right? I'm going to write another command, ionic serve, right? And this, by the way, is in the documentation for ionic. Sorry, I need to go inside the project Nyla, right? And I need to run ionic serve, right? Enter. Not to stray away from topic, I'm just showing you how the commands will allow you to do a series of things. So this is me creating a mobile app or starting a mobile app, running a series of commands, and it has a beautiful container for me, which automatically will open inside my browser once it's complete or finished compiling. So give it some time, bringing in some dependencies, bringing in some more dependencies, compiling everything, putting it all into its place, right? Still compiling. Give it some time. So I thought that, all right, so beautiful, it's finished, right? So when I opened this, right, all of this was just created by me writing bunch of commands. So I have a working tab mobile application in a container ready to go. And I can throw in from different devices to see how it look on a mobile phone, like an Android phone, or it look like. So I have an app container here, right? And I can explore different things from there. But all I did here was write three commands as you guys just saw, but it powered an entire project here that can work properly on a mobile phone, right? So I just wanted to do that, and that for Dr. Palmer is how you'd run a project. So running a project for me, when you get to Ionic stage, it's Ionic serve, right? Um, Let me just delete this app. Let me just stop it. So this is a terminal. Let me just come out of the terminal. Just going to delete a few things. Going inside the folder, removing this entirely, right? So it's removed here as well, right? So it's back to square one, as I stated before. There are many other things we can do using it. So let's come out of this. So I can navigate my directory. I can list things in my directory. So give me a second. Let me just delete this terminal. So CLI allows me to do things like I am inside of the Nyla folder, right? So I just type ls and there was nothing printed. However, I'm going to create a HTML file, right? Call it index.html file, right? I'm going to press this again, right? It shows me that inside my HTML file is an index.html file. Hello. So that is where we're seeing where that is what CLI allows it. It allows it to interact with the computer on a very personal level. So it's coding in itself, but it's just another language to learn, right? But don't worry about that too much. Let's go back to the lesson of JavaScript, right? So we were saying that let me close this. This in itself is just another editor. It's just another editor. I don't think that was the example we're tackling. All right, yeah. This in itself is another editor. So let's say we want to copy and paste this whole thing into Visual Studio Code. What would that look like? So going back to Visual Studio Code, I can paste the whole thing. It's the same thing that we're familiar with, guys. So let me just format this quickly, just so it can look more appealing, right? So what we're seeing here is a body tag, HTML tag, script tag for scripting. So remember we had style tag. We can write a script tag here that does the same thing that this is doing here as the editor, right? So what the example here is trying to demonstrate is we're trying to get the element by ID, which is this paragraph tag. And inside of it, we want to put my first JavaScript. It's already there, right? When you run the code, it's there. You can change this to welcome to Nyla, right? And we run it, and you see it turn welcome to Nyla. So in essence, we're just trying to print inside of this paragraph tag, welcome to Nyla. So we're seeing we're dynamically adding values to the screen. So let's say if the same thing works inside Visual Studio Code. So like I said, this is just an editor. It has nothing to do with running the code per se. HTML, you don't need to run it yet, right? Right now, HTML at this very basic level, we can just open it as a file. So I'm just going to save this HTML file. I'm going to navigate to my desktop and I'm going to open it outside. And as you can see, my first JavaScript is printed on screen. And if we change it inside of our file here, we can just say, all right, same thing I will say, welcome to Nyla, right? Exclamation save. I go back to this and refresh, welcome to Nyla. Let's say we want to change this tag here. Let's see how we can probably go about that. Maybe we give it an ID. So ID of header message. And remember, this is dynamic as well. So the key here is identifying what is dynamic and what is not. So let's see if we can probably create another document, right? A document get element by ID. And it's beautiful because as I mentioned before, there are many ways to reference a document. So I can get it by class name. So maybe this was class and not ID, right? I can get it by class name, right? And as I reference a document, you see the different options. So get by ID, get by name. You can also give it a name as well. So that can be a name equals the same thing. So it's just a way to reference a specific element inside the HTML document. So we're working with IDs, and it's best practice to work with IDs because ID, as I said, they're uniquely identified. So we want to, inside of that element, we want to get a header message because that's the name of this ID that we're using, right? Copying this and paste it in here. And inside the inner HTML, right? I want to say this is an amazing class, right? I'm going to save that, and let's see if that works. Refresh. Oh, it overrides what was written in HTML to what is JavaScript. So it shows who's in charge. JavaScript ran, and it didn't show this. But is that truly what happened? So there's a point I want to note. All right, so I remember I was telling you guys that inside your head tag is where you probably have your style tag, right? And there's a reason why they placed JavaScript at the end of the document. So what is really happening here is it opens the JavaScript in body, right? This message is still printed on screen. However, when it gets to this step, which is the script tag, it then changes the thing to this is an amazing class. We can't see because it moves too fast, right? But if you refresh, it's kind of difficult to see, but that is really what's happening. It defines this first, and then JavaScript overrides the content of the HTML file to display this is an amazing class. So what we're getting at is it's recommended that JavaScript is at the bottom of your document as opposed to the top because JavaScript tends to get very heavy. And in performing these actions, they can slow the load of the page. So let's say we wanted to have this up here, right? If we had more JavaScript content here, it would take a while to load actual message onto the screen, right? But you can't appreciate it now because it's still a lightweight project, and you see it doesn't work because it's inside the header file instead of the body file. But the idea here is never to define it on top of your HTML code. Keep it at the last part of it. So your script tag, you'll find that it's always at the bottom of the screen, right? Because JavaScript is heavy and it tends to take some time to load and it will throw off the performance of your site. So let me just move on to another example. That was just to demonstrate that this is just an editor. So you guys, you don't need to use Visual Studio Code. You can actually edit code right here and it works. So let me just do the same example that we just did to prove that. So we're going to copy our IDs from the H2 tag. We're going to paste it inside here. And we want to copy this document, this JavaScript code, and paste it here. And we're going to run it, and it works the same way. So this is an online editor that you can use just in case you don't want to copy and paste things. Just break things here and run it. Break things and run it. Change up things, manipulate things as you want, and just run it. All works the same. All right, so just moving on to another example. So JavaScript. All right, so functions. This is a brilliant example. I think it should wrap up the class. I'm going to wrap it up with these set of examples. So try it yourself. This is where things get a little complex, right, guys? So don't panic. This is where function makes your code beautiful. So here we have the on-click referencing a function as opposed to this entire message, right? So if we change this, so let's try it for now. So what should happen here is on-clicking this, I need to call this function. And that's what I call it in programming. I'm calling a function. So inside this function, what is really happening in this document, we're getting the ID same way, that is demo, and we change it into paragraph change. So let's try it. Right? Paragraph change occurred. The same thing worked. However, you realize, let's compare this to what we had in our code. Document that it's a little messy, right? It's a little messy to make that reference inside the script tag. And just imagine if we had this on-click reference in this entire thing here, you realize the same issue that we had with CSS. Things are bombarding the HTML code and want to keep that degree of separation going, right? So the fundamentals, like I stated before, is just calling a function that does this specific action. But if we copy and paste the whole thing here, will it still work? Well, let's find out. So I'm just going to copy this out. I'm going to replace my function with this entire thing. So you see, things get messy just now, right? It look a bit tacky. Let me just use a single quote. All right. And let's run it. I'm going to remove this function for now and run it. Let's see if it still works. All right, that broke something. Give me a second. All right, in a HTML document, don't need this. Change document element. All right, let's go back a little. Might have copy and paste the wrong part of it. All right, so in comparison to what just happened is we want this same example. Copy this out. Let's paste this. Just paste this. Should be good to go. I'll explain what I'm doing soon. What was happening is there was a conflict. All right, nice. So there was a conflict between these open codes, right, and the codes that were inside. So the JavaScript introduced something that is called single quotes as opposed to double quotes. Because if you have a double quote here, it will confuse the computer. So this is how dumb a computer is. So it's going to say this is the open quotation. However, this would be the closed quotation. So it ignores everything onwards, right? But we're using a single quote, we're allowed to have that reference point. So we know that this double quote belongs to this double quote. Similar to how when you open a tag, you have to close the tag. Everything is mapping. So this single code reference to this single code, this single code reference to this single code. But this is just schematics. Don't need to worry about it. The idea that we're trying to prove here is, will it work without this function? If we call the entire thing that's inside the function here. So I'm going to copy this and remove it from the code and run and try it. Nice. Still works. But you see this mess, like it's a button inside HTML, right? It's a bit messy. So they're trying to get that degree of separation going. So instead of seeing all that junk, let's define a function and call it. This is where, as I said, a variable differ from actual functions. So there is also a date function, there's also a date, right? But these are custom built functions. So we can change this to anything. We can call this grave, right? And I'm calling it ridiculous names so you guys can actually remember that you can call it anything and run. Let's see if it still works. It still works, right? We can call this anything. We can call this car, copy and paste it. As long as the name is the same in the call, it will work all the time. So see, it still works. So this, you give it any particular name. JavaScript knows the function because they call this function keywords. So these are things they call keywords as well, and what it represents. So let's look at the final example before we call it a close. So something that is a little bit more complex, just to show that it doesn't change. All right, this is interesting. All right, so what it is saying here is you can reference an external JavaScript file using this. So remember, you guys we're expounding on the fact that you can use inline CSS where we had the style inline with this and put in the raw CSS code inside there. So same font size, right? For example, is 10 pixel. JavaScript in the same has its inline function. So I can write the stuff inline here, right? I can write the document. So I can write document dot get element by ID, right? Right, and I continue on. So I can write raw JavaScript there, or I can reference a function called my function to make it a little smaller. I can write inside of my script tag here, as we've done in our previous example, the rows inside a script tag, or we can have an external JavaScript file to remove this clutter. So let's use this example to do that, just that, right? We're going to create another file, and just like CSS and just like HTML, JavaScript in itself is a file too, right? So we tend to use the script.js. So JS defines it as a JavaScript file. And I had this coolest extension installed on my computer that changes the icon based on the file that we're referencing. So inside here, we can actually write JavaScript code. Can we? Let's try and let's see what happens, right? So I'm going to take this entire script because we no longer want it inside here. And I'm going to paste it inside my JavaScript file, right? So all the elements are separating things. So now we're looking at strictly HTML code. We're not bombarding things. We're not putting JavaScript stuff in here. Maybe we should create a function. No, let's just work with it as it is, right? So now what we wanted to know is just like CSS, reference our JavaScript file, which is what they were doing in this example. So it has an attribute called source, right? The source attribute allows me to reference my JavaScript file. So my JavaScript file is called script. So let's locate that. All right, nice editor does the work for me. And let's save. Will it work? Maybe it won't, right? Maybe it will. So let's check our browser. We already had the example open, which was here. Let's refresh. Nice. It still works. However, it's much cleaner. So as opposed to having, so let's go back on what we had before, right? I'm just pressing undo. You're looking at all this clutter, but you're in an HTML file. You don't want to be seeing JavaScript in your file. Jams, I'm gonna call you back in a class. Well, next close to the office. Why? All right, let me send you my location. I'm close to the office, right across from the office. Yeah, man, no problem. All right, just give me a second, guys. I'm gonna send my location quickly. Um, okay. Oops. No, 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 no. Abort. All right. So share current location. Cool. All right, yeah, man. So we're looking at our HTML file, but we can have JavaScript here. And as I tell you, guys, you can choose to do it this way. You can choose to do it any other way. But if anybody is going to take you serious, if you turn up for interview, they want to see that degree of separation. They want to see that cleanliness. This is a JavaScript file, have JavaScript inside there. This is a HTML file, have HTML inside there. So it's going to undo a few things. No, it's just the other way. Give me a second. All right, just going to do it again. I'm just going to remove everything again, the clutter, and let's reference a file because it takes away, it applies that degree of separation, right? I'm just referencing the file, and I save, and it works anyway. So refresh, and if we change stuff from the JavaScript file, so we had a capital H for this. Maybe we add some gibberish to the string value, right? Save it and refresh. It will show the gibberish as well. So the verbiage becomes much cleaner. We know that this is JavaScript. However, if we want to reference it, we can click Command and click to the file that it's stored in. So ideally, what they're doing for this example is the same thing. So they created a MyScript.js file, and inside that MyScript.js file, they had a my function file, a my function function existing, right? So what this is saying is, this example was to find where to. So my function is stored in an external file called JavaScript. So what they were trying to grasp here with this concept is that you can do the very same thing using an external JavaScript file. You can create something powerful. You can create a button, right? Let's create our own button and see. Right, so button, we want on click something to happen. And you see automatically detects. We want to call a function called alert. So let's do something that's kind of interesting, right? We want an alert function to be called, and we want to close the button. We want to give it a name that pick me show alert, right? That's for something that is more appropriate or in line with it. So let's save this and see what happens. Let's go back to our file that is open, refresh. So we now have a button that says click me to show alert. Wow, the alert just works, right? It works because alert in itself is a built-in JavaScript function and it's referenced in JavaScript here. However, let's say we remove it and call it something else, like my function, as they've been doing, right? And save and refresh and click, nothing will happen. The only way something can happen to show alert is if we in ourselves decide that, all right, maybe we want to reference something outside of this function that has a my function call. So let's define a my function outside of this, inside our JavaScript file. And as I said, things can get really messy. You can just have it as messy as you want it to be. But in essence, what we're doing is writing JavaScript code, finding the function. So this function keyword allows JavaScript to know that we're creating a function. What do we want to happen? We want to show an alert whenever this function is called. Maybe it will work, maybe it won't. We're just trying things, right? Save that, let's refresh and press, it works, right? So let's say we want to show a little message inside of an alert. Inside an alert, we can say, welcome to this awesomely amazing class, right? Exclamation and save it and refresh and let's click. So we're seeing that the message is being displayed at the top. So welcome to this amazingly awesome class. And if you want to get a grasp on what is alert or what the different functionalities are, the default functionalities are for JavaScript, then you can always check. References will drop. It will be placed in the notes for you guys to see. But JavaScript functions, if you type this, you're supposed to get everything. Probably default functions. Right. So default parameters, default parameters, default functions. So here you'll probably get a series or a list of functions that may exist in JavaScript. But there are some default things that JavaScript already does outside of the box that you can look for. So JavaScript by itself, this will also be inside of the resource document that will be shared later on. But what we're trying to grasp here is in creating this reference to this, it allows us to open a wide world of JavaScript files, JavaScript functionalities over on this JavaScript. So you can build a lot of things, and that's where the degree of separation comes in. So if anybody asks how to run JavaScript, this is how you go about it. It's still creating the HTML document, however, you're referencing a script file or a file that is called .javascript to get all the different functions here. And for Clojure, another beautiful thing that you can tap into is the actual engine that is built inside of the browser. So the browser by itself has an engine built in. So using console, as they call it, you can tamper with the engine. So remember last class I did show you guys you can do basic arithmetics. You can do console logs to display something to the screen. So logs, hello everyone. I guess I did it already, so I just remembered. Hello everyone. Right in the same console log. Hello everyone, it's printed at the bottom of the screen. We can tamper with some JavaScript. We can probably create, let's see if we can manipulate this header tag inside of our console. Let's see what would happen, right? So we want to say document. So when I reference document, right, you realize I'm interacting with the browser, which is the V8 engine for Chrome, right? So every time you say an update, it's usually an update to the V8 engine. You guys can do some research on that. Let me just remove that, I get some space. So I'm going to type document. And when I type document, it highlights the entire document, right? Just to show you guys again, because this in itself is a document, right? So we want a document and we want a specific item. We want an item. So we have a bunch of functions that we can tap into. However, we know what we want. We're going to get an element by ID. Get an element by ID because we know the ID for this is header message. Inside the element by ID, we want to get this specific ID. Want to dynamically change it just using a browser alone, right? If you want to run random JavaScript dot. Okay. So in a HTML, sure, I'm not getting any predictive text for that. Let's write it anyways. I want to change that to something else. All right, let's close that, press enter. All right, so we're looking at the left and realize that it has changed. I'm just going to copy and paste it just so you guys can get the appreciation. Refresh, and this in itself already has this, right? But I want to change some things a little deeper, right? I want to change it to something else. Enter, it updates the document itself to change to something else. So I'm editing JavaScript in real time. And if you guys want to have a little more fun, you can probably go to a site that you're already familiar with. I was using Apple or maybe something more minimal, so google.com, right? I want to do some manipulations here using my JavaScript knowledge that I just learned. So I'm looking up here and I'm realizing there's a lot of clutter, but there are things that we're already familiar with, right? We have class, we have style, which is display none. There are things that we're already familiar with on Google page, but we're looking at something that we want to modify. So maybe we want to modify an image, right? We already went through this, so we want to change perhaps the source code into something more appropriate. All right, we want to change this Google image to something else. So let's go to our console, right? Console is where you go to edit JavaScript, right? Raw JavaScript. So we're looking for the ID for that image. The ID is HP logo. We want this ID, right? So we're going to reference our document, which is the entire thing, right? We want to get the element by ID because we're trying to reference that specific element. And inside the ID, we need to reference the ID that we just copied, right? And then what do we want to do? We want to change the source, which is that specific attribute, right? To an image, a different image. Let's see how that would do. So we know that we can reference source now because we have access to the element, right? And inside the source, we perhaps want to change to something funky, something else. Let's just get a random image from the web. I'll just use dollar financials. This is a site that my company had created. So just copying this and I'm going to paste it inside here. I'm going to close it and I'm going to try to close that as well and put that enter. All right, it's not a function. All right, I might have missed something. Give me a second. Reference source element. Right, perfect. So it's I'll start to it as it comes, right? Okay, so a mistake. So it wasn't a function, it was an attribute. So attribute equal to the thing. So just correcting my wrongs, going back to the page. So the computer is smart enough to know the protocols or the way that you're supposed to follow. So let's do that one more time. So document, right? Dot get element by ID. Inside of it, we want the same HP logo because that's the element name. We want to reference to source and we want to change it to what we just copied, which is dollar financials PNG. All right, now the error again. Let's press up and throw encompass or encapsulate that in some quotations. right? Press enter. So it's not changing it. Just give me a second. I think. Why are you not changing? Google put some override stuff on there. Oh, well, it updated. All right. All right. Sorry. So they set it to many things, right? So we're seeing that source set, but we're seeing that Dollar Financials logo was applied. However, it's still referencing some other things. So let's see which one we really need to change. Maybe change the source set. I'm just going to test the concept before I apply it. Just to ensure we get the right thing. Change this, press enter. All right, perfect. So this is exactly what we want to change. So the source set, let's go back to our previous example. So it's not source anymore. We're trying to get the source set. So src set. Let's copy this out to refresh the page back to Google. And I want to do the same thing to that and press enter. All right, perfect. So that is how, like I said, this is how hacking work as well. Sometimes you run it into roadblocks and you're wondering why things aren't working. And I was humble enough to look inside myself to see an example that requires me to think, right? So I thought it was a source. However, Google implemented their own attributes that is called source set because source set is not a typical attribute you'd use. You use source for images, right? So I just tap into what Google used and I use raw JavaScript to manipulate the function of the page, right? Let me just do another example just for closure. I want to remove this specific button, right? This is called the input button. We realize that we have a class, we realize we have values, we realize we have a name. Maybe we want to use the name this time as opposed to the ID, right? Let's just try the name and see what happens. So document, we're referencing the entire document. We want to get the element by the name this time, right? Not by the ID, but by the name. So the name was ETNK, copying this, and I'm going to paste it there, right? And I'm just going to close that. So what I want to do as well is I want to change the style, right? I want to change the style to, so not going to text show off, so JavaScript, change display, and but it's trying to get the actual code to do that. So I want this code. So ideally I want to change the display to none, which hides the element, right? So going back here, I want to just paste this in, just store that and press enter. Right, so set property display of define. All right, just need to confirm here that there's actually a display CSS code applied. So we're seeing that there's an inline display. So just troubleshooting a few things. Right, so the name, are you restricting me, Google? Of undefined. So it's not finding the element by name. Set property, cannot set property of undefined. Is it undefined though? Just checking that the name is actually that. All right, let's give it an ID because Google have some weird algorithm in the back that is causing some blockage. I want to get the example or the point across. So I'm just going to create an ID that I can reference, something unique. I don't think Google will call a button a Nyla button, right? So just editing that to match what we're trying to do. So we're using get element by ID. So sometimes JavaScript have some difficulties finding the element themselves. So let's just use ID for example's sake. So get an element by ID, right? And we just call it Nyla button. So Nyla button, right? I want to change the dot style, dot display to none, and press enter. All right, perfect. So you just hit the button, right? And just for those who probably missed it just now, and I'm just showing you how you can dynamically mess around with websites. And it doesn't change it, but you learn a lot from it, right? So going back to our source, what we did, we're trying to hide this button from the site using JavaScript. We gave it an ID name of, let me just edit the HTML right here, giving it the ID of ID equals to Nyla button is always able to use, right? and close that. Create in the HTML code to reflect that. So the ID is Nyla button, just confirming that. The naming conventions are very important, or else it won't work. So if I put Nyla with common N and I press enter, it will not work. Right? It cannot find the style of null. But if I was to change the capital N, right, and press enter, you realize that Google search has been removed. So you're dynamically editing and manipulating things. And this is what they call a DOM, which is a document object model. We'll get into later on. But the idea here is real time. In real time, you can manipulate websites using JavaScript. You can use it, manipulate it using CSS. So remember last week we spoke on using CSS to do a different things. So change the color, changing the actual colors, applying different text, and you can change it using HTML. So you can inject your own HTML code into this thing as well. So under the image, maybe you want to create something else. So edit as HTML, you can put your own verbiage there for better appreciation. Some random things, close an HTML tag, and enter. So it's being blocked here, but let's hide this element. Let's remove it for a sec just so we can see things clearly. Just going to delete this because I don't want to see it anymore. Right. And here's our gibberish. So we can edit things in real time. We can really expand on our knowledge by just using the browser alone because the browser has grown so much, so tremendously that we can start to manipulate things in real time, as you see right here. And that pretty much concludes the lessons for today. Everything that was discussed will be available in the resources that is presented between now and tomorrow. If you guys have any question right now, would be a great time to ask it, and I'll be more than happy to answer it for you guys. Stop sharing the screen. All right. So when we reach the CLI interface part of the class, we'll go deeper into how the CLI do things. Correct. That's amazing how JavaScript gives things life and animation. That is facts. Oh, this is cool. It is. It really is. It's pretty dope. And that's the fundamentals of it. And like I said, when you start to create things, like I'll just give you guys an example of something I was working on recently. And I use JavaScript to build the whole thing. No, I rather not. Let me not show it. No, it's fine. All right, never mind. But it gives you the power. It opens a new world to you for you to access a certain set of things, and you realize it doesn't not introduce itself properly. It just introduce itself seamlessly into the HTML document that you already have. Once you know the constructs, you can play around with it. W3 schools have all the information. You can start making buttons jump. You can make it start moving all over the place. But that is just a series of functions, as we stated before. There's nothing overly complex about it. You're referencing a document. You're trying to get the element that you're referencing, and you're making that element do a particular action. That is it in a nutshell. JavaScript. So no questions, guys? All right, so two message. No problem, Sanya. So basically, if you know, I guess, well, if you know, you know. Hold on. AJ. All right, I'm coming in 5 minutes. Yeah, man. Yeah, man. So as stated before, guys, this I'll compile a document between now and Monday to hand over to you guys to get deeper into JavaScript. But remember, the concept behind Nyla is for you guys to grasp the fundamentals. So when you grasp the fundamentals, then the skyscraper won't look as scary because you know that what you're embracing is just a series of bricks that led to that skyscraper. Brick on brick, right? So you could technically teach yourself animation. It's the same concept. It's the same concept, Joel. And I like how you see it. That's exactly it. So learning to animate things can be your specialty. And if you grasp JavaScript, you realize that some really like the Scotiabank app was written using JavaScript, the same fundamental document reference type. Huh? They use React. So React is another JavaScript framework. So a lot of the apps that you're familiar with, Facebook was built using React.js. It's strictly JavaScript. The Google browser was used JavaScript built that as well. And many other things like everything that you can, most of the things that you can probably think of was built using JavaScript. And there's this argument, like I just talking loosely now. So there's this argument about whether to build using native when you're using mobile apps. So you can use Java to build it, You can use C Sharp or Swift programming language to build it, or you can use JavaScript. So the same functionality, because what they used to differ whether a mobile app is performing well or not is 60 FPS, which is frame per second, which is the performance of the app itself. And JavaScript has caught up to that. So there's no degree of separation. Eyes can only see 60 FPS, right? So if once the eyes anything above 60 FPS is just ridiculous. You can't see it, right? You can't see it. So the eyes only see 60 FPS per second. So JavaScript has gotten there, and JavaScript is so powerful, guys. I mean, when we start developing mobile apps, you start to see the beauty of JavaScript. Yeah. Huh? Oh, where is this class located? We're on a mass. I think I would want to attend the physical class. Yeah, man. We can drop the location, but we have maintaining the 6 feet apart. To be honest, but for me, not like Bujo or anything. I don't subscribe to it. I try to, as a part of being a slight Rastafarian, is like I trust God a lot, and I trust in His plan. So, but I still maintain the same precautions, right? So I think that whatever your mind can conceive, then you can achieve it. So I don't think about COVID. I think about God every day. I think about God navigating me through this time. I think about how much control He has. That if I'm going to get this thing, I'm going to get it. I still interact with people on a daily. I've done the tests, everything worked out, and still COVID free. I'm just living life. I'm just being happy. I'm just appreciating God's creation and His beauty, God's plan and everything. And well said, Sonia. God help those who help themselves. So it's just like for me, I have so much faith in Him and I have so much faith in His plan that whatever is to be unfolded for me, it will be unfolded in due course. Because I can make all the plans I want. I can wear the mask all I want. If God don't want to give me COVID, I'm going to get COVID. If God don't want to give me COVID, then I'm going to get it. So I try not to lose love because of COVID, and it's hard in the hearts of people. Like we're still people at the end of the day. People still need love and compassion. You don't need to scare off the other member of society because you have COVID. Oh, stay close. Just continue to love one another. It's just that's the fundamental message, really. So sorry for not wearing a mask, Joe. That is my thought process in summary. But we still maintain the protocols. All right, no problem, Joel. Yeah, man, anytime. And guys, appreciate that, Joe. So, guys, just remember, we're forming a community, or we formed a community where we can share different perspective, bounce ideas of each other. And at the end of the class, I really want you guys to work on a project together. I want like a collaborative execution where you guys to build something that is used in the world today. So start thinking of ideas, because trust me, you guys will have the ability to do so. You guys already have 80% of what you need to build something amazing. You already know HTML, you already know JavaScript, you already know CSS. Guys, you can start building today. So if there's any idea that you have that you want to execute, and let's list it in the class and we'll tackle it together. Oh yeah, CSS and HTML. I'll put it in an assignment. Yeah, man. So we're coming with a challenge. I don't like calling an assignment because we don't subscribe to the typical schooling mechanism. So we're bringing a challenge this week for you guys to implement what you've learned. It will be on top of a lot of things that was never thought or taught. Sorry, do some research on JavaScript, get familiar, you get the fundamentals down, you're referencing a document, you're trying to find the ID or the element that you're trying to change, and you apply and change the element. That is, once you understand that, everything is the breeze. And you realize that programming isn't as difficult as they make it seem. They just bombard you with a lot of verbiage. It scares you. But it's very simple, guys. Opportunities is there in the market, and trust me, man. All right, so I gotta do my outstanding assignment. I know I have so more time. All right, nice. That's good, Sanya. I'm happy to hear that. All right, Nico, yeah, man, for sure. Yeah, man, you guys can come in person if you want. We have the space available. That's why we're here. If you don't necessarily want to interact over the camera, then it's kind of much more difficult to do so. Come, we can walk you through things. We can teach you additional things. But yeah, you guys are pretty equipped now. So start building some things. Show me something next week. just like maths, right? So if you know the formulas, as Joe was saying, that programming is like knowing and remembering like the formulas in maths. It's just like if you know the syntax, guys, you know what everything does. You put it together a collection of syntax to execute on a particular task, and you can create your own syntax, create your own verbiage, and apply it. And yeah, you will. That's all it is really. So people, I guess they start coding school. Like for example, when I was starting programming, for me to do some of my certificates, I had to pay like 200,000 Jamaican to subscribe to programs that I can get a piece of paper to show that I'm competent. I'm like, but why do you have to do? It's like I used to go to class for every Saturday for 6 months to get this certificate. When I was achieved like I have to buy a book. I remember when I was getting Java certified, right? I had to buy a book this thick, right? This thing, and I had to read through, and I sat in the exam. And it's like I had to know. So it's, that's why certain things stick with me. I just never forget it because I went through the work. I know all the fundamentals. I know the code. So when I was reading through the book, I was like, why does it have to be so difficult? At the end of the day, reading the book, you can't build nothing. At the end of the day, all I know are just theories and concept and constructs. And where if statement do and for loops and while loops. But I can't, I still could have been nothing. 'Cause the amount of reading I do, my creativity gone, with it. The brain tired. But the idea we want is keep that creativity. You know the syntax, but be creative about it. Build something. Just wake up, have a problem you want to solve. Probably want to create a form for collect some data. Create a form for collect data. You know have the knowledge to do it. So I want to thank you guys for showing up at this class today. Like I said, next week will be a lot of going through pretty much the same things and going a little deeper. But I'm going to start interacting more with my computer as opposed to the whiteboard. The whiteboard is for breaking down the fundamentals on a humanistic level until we touch the computer, we start operating like computers. So that is it in a nutshell, guys. And I want to thank you guys for coming. Dre will have his closing words. I'm going to make a run now. But love you guys. Take care. See you next week.
All right, guys. All right, guys. So sorry about that. Sorry about the echo. Mute the system. Mhm. All right. So thank you guys for coming out as usual. I'll be posting some updates in the WhatsApp group, and um, like clockwork, I'm asking you guys to just interact in the group, please. If you have any questions, ask. Don't if for the questions, those don't message me privately for the questions. Just put it in the group because some other persons may not know, um, or maybe considering the same questions that you guys have and would benefit from it just being a public thing. But if you have feedback on the syllabus or you really think that asking me personally is necessary, then I have no problem with that. But again, thank you guys for coming out. We look forward to seeing you guys next week. And we have some more announcements for you because we want to go deeper into even, engineering databases, building out and this is actually based on a discussion that we had with one of the students in Nyla, teaching you guys how to handle APIs, server-side stuff. So just look out for those announcements and updates in the syllabus. So yeah, that's basically it. Have a good weekend, guys. See you next week.